record. So as of now, this meeting is being recorded, which you say will be recorded. So you all know that. So does our speaker. I introduced my guest speaker this way. You've seen the flyer. I'm very excited that he agreed to talk with us for a couple of good reasons. For one thing, her work certainly intersects with the work we do. And I think that the kind of science that I know she does, I want to expose all of our PhD students to it. So I am pleased that she'll talk a little bit about how the brain works and a little bit about how language is formed. And I think that will help all of us. So I won't do a whole lot more of where she was educated and all those other things that people often do. I'm just going to close this up and turn the screen over to you, Dr. Datta. Let me bring you up. There you go. That little endpoint thing is going to happen the whole time. All you need to do is keep you've been in these rooms. So you can use the up and down. You don't need to stand by the microphone at all.
Okay. Thank you so much for that introduction. Thank you so much for inviting me. I'm so excited to talk to you. I gave a 2 a.m. version of this talk today in India through Skype.
I love that. That's what we need to do.
So I'm excited to see what you all think about it. Those of you who are in the room, you can see me, right? Me. Oh, okay. Because often people can't see me behind the podium.
Can you stand up, please?
I can sit on that chair. All right. So the title of my talk is Speak More Than One Language. Here's how your brain does it. So I'm going to take you through a little bit of background about bilingualism and then talk to you about a series of studies that I have been involved in to demonstrate how the brain juggles languages with the help of attention. Okay, so let's get started. This is a New York Times headline, not a headline, but a article from 2013. It says, new study shows brain benefits of bilingualism. You have a nice colorful picture there, which is captioned by saying an Indian schoolgirl dressed in Telugu Tali poses for a camera during a celebration in Hyderabad, home to a study that seems to show onset of dementia is delayed for people who speak more than one language. The next slide shows, I have animation, which I didn't realize. The next slide shows a series of these articles that have been published in New York Times science sections and other popular places over the last decade, highlighting the advantages that we can look forward to if we speak more than one languages. And in this room at this time, we might be thinking, what's the big deal about that? But the context to this is that in the early 60s and 70s, and even earlier than that, speaking anything other than English wasn't celebrated as much as it is today. So this is taking quite a turn, and although I do want to tell you at the onset of this talk that this doesn't mean that bilinguals are smarter in any way, in the sort of popular sense of the word. It just means that different people are good at different things. Okay, so this is often a question that the popular public might ask, who is a bilingual? And every time I ask this question in class, I'm sorry, my accent changed because I was doing this talk in India, which is something I do a lot. I have to switch. So when I ask my students in class about who's a bilingual, often I won't even see one hand raised. And that's because the popular belief is a bilingual is somebody who can very easily converse in 2 languages and feel no effort in doing so. So if I switch now, Arami Banglate kotha boli, and I can switch back and talk in English again, you think, oh, she's a bilingual. But in the literature and in the world, exposure to 2 languages at any level changes your brain. So I would like to ask the question in the live room right now, how many of you have had any exposure to a language other than English? Anyway, so now we see so many hands go up. And how many of you would say you are conversational in more than one language? and now we have 2 hands, and so we have the whole range. That's what I'm trying to talk about in terms of how we deal with who's a bilingual in the world and in literature. So I am sure that actually, before I start this, that's my phone, I think. I just want to mute it so that I don't disturb anybody. No.
You're the only one who heard it.
Oh, really?
Yeah, don't worry about it.
But if it rings, it will be too loud. Okay, so I want to talk about when is it a good time to learn a language, because that is also a popular question in the world. So even though there are not a lot of questions about bilinguals and bilingual brain that have been solved, shall we say, one thing is for sure, that the earlier we learn a second language, the easier it is. That's been established. There's no argument about that in the literature or in the popular world. So acquisition of 2 languages or more, right? We should be aware that the languages influence each other as we're learning them, and age of acquisition is always a predictor of success in the second language. Another thing that I want to set out right in the beginning is you're going to see this notation L1 and L2 a lot. L1 stands for first language and L2 stands for second language, and that is to do with the order of acquisition. So that is to say, L2 can be your dominant language, which I think my L2 is now, which is English, obviously. I speak 2.5 other languages. But I would say English is my dominant language. That's what I'm using mostly with most people in the world for the past 20 years. So, but that doesn't mean it's my first language. Okay. All right, so this is a graph from a study by a person whose last name is Birdsong and his student Molloy, which is actually a replication of a pioneering study by another set of people, Johnson and Newport, from 1989. So if you look at this little inset here, it says JNN and BNM. So JNM is data from our data from the old study. These black dots and the open, the white triangles and circles are data from the more recent study. And the Johnson-Newport study is from as early as 1989. And what these people did was they looked at language skills in immigrants who came to the United States. Okay, so what you have on the x-axis is age of arrival in years, and 0 means you were born here. And as you can see, they track people all the way up to people who've arrived in the United States at 45 years of age. And then on the y-axis, this is their task was grammaticality judgment. So what they did was, to these Korean immigrants who came to this country, they gave a set of 276 sentences, and some were grammatical and others were not. And they were asked to simply say, listen to the sentence and tell me if it's correct. And what you see, as expected, is the best performance are by people who either were born here or arrived very, very early, right? Those, for both studies, those are the diamonds and the triangle, the early arrivals, as you can see at the key. And as you arrive later and later in your second language environment, this task got harder and harder for you, right? Mm-hmm. And this is at the perception level even. They're not testing production of grammatical sentences. They're just seeing if you can tell if these sentences are grammatical in English or not. So as you can see that around the age of 15 or 16, there's this sharp angle in the graph that suggests that it might just get particularly difficult if you learn a second language after that age. And just some interesting context, these studies which mark what we consider a sensitive period for a second language acquisition come after a series of studies and ideas which suggested that one can only learn a second language up until puberty. And after that, you cannot learn one. And at that time in the 1960s, this idea was termed as critical period instead of sensitive period. And the idea was that our brains are biologically not receptive to learning a second language after puberty. But these kinds of studies show that it's not that you can't learn it at all, but it just gets more difficult. And that nobody has any problems with any longer. Okay. So now, the other thing that I want you to be aware of is when we say language, it seems it's such a broad term to, maybe not to you, but to those of us who are speech language pathologists or in communication science and disorders, we sort of pull apart language in many different ways, and different parameters or different aspects of language have different, we learn them differently and with different levels of difficulty. So in my studies that I'm going to talk about today, I'm going to talk about sounds and words, but this one other one that I just mentioned had to do with grammar. And then, of course, there are studies with also continuous speech, like how you're hearing me talk, which are, of course, the more natural and ecological ones. And you might argue that they're the ones that matter, but as a discipline that sort of largely resort to the psychological sort of setup for experiments, we tend to break apart things and go variable by variable. So the first set of studies that I'm going to talk about has to do with speech sound processing in early and late bilingual Spanish English speakers. And these set of studies I did with my advisors and team at the Graduate Center when I was a student, although one of the studies is getting published. I have the proofs. It's a very, very long time in the making. Okay, so first I'm going to talk about adults. So this is the paper that I'm going to talk about first. The name of the paper is ERP Indices of Vowel Processing in Spanish English Bilinguals. And all of these studies where I'm talking about sound processing, we're going to deal with these very largely weird sounding vowels, as you will see. And the first set of studies are about adults, and we were focusing on adults who learned their second language early, as well as those who learned them late. So the goal of this study was to determine to what extent bilingual exposure to Spanish and English affects the processing of speech sounds, which are present in English but not in Spanish. All right, and even though I briefly talked about how late learning and early learning is, I'm going to define that for you for our study. So our late learners were those individuals whose first language was Spanish and they arrived in the United States at 18 or older. And our early learners for this study were people who learned Spanish and English both before the age of 5. So they could have learned it together. That is, maybe their parents both spoke Spanish and English to them, or one parent was Spanish and one was speaking English, or their grandparents lived with them, whatever. Or they might have had Spanish at home, but as soon as they go to daycare or preschool or what have you, they're exposed to English. Right, so but both before the age of 5. All right, so the questions we asked in this study was, how does the amount of second language exposure, remember L2 is second language, affect processing from vowel contrast that's not present in one's native language? Native here being Spanish, that is an English vowel contrast. And we wanted to know how that works at an attention-dependent level and at a pre-attentive level. So again, to sort of set context for all of you, you're all paying attention. I mean, I'm hoping you're all paying attention to me as I'm speaking, but you're not really paying attention to the sounds I'm actually saying, right? That is very automatic for you. You're not thinking that I am these sounds to say saying, right? You kind of, as it's coming, you're processing it. So that's pre-attentive. And attention dependent is if I now told you, okay, I'm going to say a word, and you tell me what sounds were in that word, and the word is word. Now you're thinking, oh, what were the sounds in the word word? Oh, the w and the and the d. So you're paying conscious attention, right, to the sound. So that's what I mean by pre-attentive and attention-dependent levels. So for the attention-dependent levels, we use these classical tasks that we see in psychology as well as speech-language pathology experiments of discriminating sounds and identifying sounds. So our participant, this is not our participant, it's some kind of photo from the web, but they would sit in front of a computer or at a table, and they had this kind of a response box that you see on the right. And for the discrimination task, they were either to press a button that said, oh, these sounds are the same if they came in pairs, or these are different, you know, the and the S sound were different. And for an identification task, these buttons were labeled as I and E. So remember I said we use these very short vowel contrasts. So the vowel contrasts we used were these two vowels, the I sound as in the word bit or pit, and the E sound as in the word pet or bet. And even though I'm pretty sure all of you get the pit and the pet, and you understand that these are different words, pit, pet, and bit, bet, people in Spanish, or if you had native Spanish speakers who had very little exposure to English, they really have a trouble pulling these sounds apart because they don't have these sounds in their repertoire. In fact, although I don't have it, the Spanish language only has 5 vowels. I don't know if any of you, I'm sure none of you are thinking, but my students would think, oh, but English has 5 vowels too. No, English has 5 letters that are vowels, but English has 13, 14, and more vowels depending on what dialect you speak. So so you can understand that as a Spanish speaker, this is difficult because, you know, I have only 5 vowels, and now I'm trying to listen to a language that has so many more distinctions, right? So this was the task. Here they got the sound in either pairs or in a continuum with some repeating sounds and then a different sound in the middle, and they had to say when they heard the different sound, or they heard one sound like just that vowel, and they had to decide, oh, did they hear a sound or a S sound, and had to label it. There. So if I hadn't told you that these are speech sounds, you might even think that, oh, are these all speech sounds? But they are. If you want to know the history of these, or how they were actually made from human voice, and they were modified to just, modified such that there were no difference between these two except for what sound they are. And you can do that by modifying frequencies and amplitude of these sounds, and we have software to do this. But my point is, they're not synthetically generated. They're actually one of my advisor's voice, and we cut it up and did all of these kinds of things to it. So these are the data from the discrimination task. So in that series of sounds, you heard sometimes the sound change, right? Mm-hmm. So the participants were asked to press a button to see when the sound changes, and you can see that the 3 groups, the monolinguals, the early bilinguals, and late bilinguals, they were comparable. They were, I would say, all good at the task. And even though the late bilinguals look like they're not as good as the other 2, but there were no statistical differences in this condition. So in this task, everybody was good. Now here is the results of the identification task. And I know the graph looks a bit odd, but I'm going to walk you through it. So the first thing I would like you to see is that the monolinguals are the first 2 bars, the early bilinguals are the middle 2 bars, and the late bilinguals the last 2 bars. And as a pattern, I would say, and I hope you agree, that monolinguals and early bilinguals, those bars, the color distributions, look somewhat similar, and the late bilinguals, they have this large red portion, and that's different. So how this graph is set up is, on the left, you have number of people. And So what we are showing you is how many people did well in the identification task, and that's blue. How many of them were at chance, and that's red, and how many were not very good at it, and that's green. And what the before and after is next I'm going to talk about the ERP task, where we record EEG data as these participants are watching a movie and listening to these sounds in the background. And the whole setup is about, maybe under an hour or so. So they hear a lot of these sounds. So we ran this identification task before they did that ERP task, where they were exposed to this for a long time. And then we did it after, thinking that since the brain got this extensive training, right, what happens next? So as you can see, both the monolinguals and the early bilinguals improved, after the test, because now the blue bar has gone up, meaning more people are doing well, and the red portion has gone down, meaning not a lot of people are at chance. But the late bilinguals, which is the last two bars, they did improve, but despite all this exposure, this last graph, you can see only about 5 people were still able to identify the it sound and the S sound well, right? So what we can say from here is that even with attention, if you learned the language late, you were not doing as well as if you learned the language early or if you were monolinguals. Okay, so now we're going to talk about the ERP part of the study, and I'm going to walk you through a little bit of why we do this and what's how the data are acquired, and how we pull apart the different conditions, etc. So this slide is just to show you that in the task that I did describe to you, because we're getting behavioral data, it's not just the language processing that is involved, or the data we are getting involved other variables than just processing of the speech sound. So whether of course, I've already told you, the participants are paying attention, and explicit attention matters. So if you were hungry and you're thinking of getting a burger just at the moment that your stimulus came, you might have missed it. After a while, this is, trust me, an extremely boring task. So, maybe some people want to, finish up and leave, and they're not so motivated. Memory skills come into play, and also motor skills for such a behavioral task. And that is to say, all behavioral tasks have some level of this complex interaction of all these variables. Getting EEG data kind of helps us focus just on the language or the speech portion of it, with minimum input from all of these other things. And that's one of the reasons that is effective for the questions we are asking, at least. So this is our setup of how we gather ERP data. This is from my advisor's lab. As you can see, these little white things, they're electrodes. This net has 64 of them, and we actually dip these sensor nets, as we call them, in a salt solution to increase conductivity. And what we are measuring is essentially the electric potentials that the neurons are passing around from each other. And this little thing is to show you that the participants in this study, they had the sounds come in the background in free field speakers, and while they were listening to the sounds, they actually were watching a movie that is closed captioned. So they were explicitly told, don't bother with the sounds, don't pay attention to them, you focus on the movie. Okay. But just like you are able to understand my speech sounds, as even though you're not focusing on it, the brain is so good at processing speech sound that they can do this even when they're not paying explicit attention to the sounds, right? So what I want to also tell you is this paradigm, it's called a oddball paradigm because there's this repeating sound, that's the S sound, and occasionally you'll hear an E sound. So this is, it's not my slide. It's a friend of mine who created this slide, but I like it. The idea is, how you have the occasional different stimulus and the repeating same stimulus. And the data we get are called event-related potentials. These are voltage fluctuations, which are the potentials that are recorded from human scalp as a result of neuronal activity. And these potentials, they're time locked or related to a sensory, motor, or cognitive stimulus, or that, which is the event, right? So in this case, this is a auditory stimulus, which is in the sensory domain, but you can use this tool for any sort of environmental stimulus. So now when we collect data, we are able to gather data from all of those 64 channels that we saw. And what we are getting is a raw EEG. And this is something you're probably all familiar with. You've heard it, or you have had somebody who's had an EEG at a medical office, or so on and so forth. They look like these squiggly lines that you see here. And what we are essentially recording here is the participants' brain's response to anything in the environment, not just to our but also to the movie he's watching, or the ice cream he wants to eat, that thought, or he's scratching his leg or whatever. All of the brain responses to that, everything is mixed up in this EEG. So what we need to do, of course, from that data is to extract the response to our stimuli of interest, in this case, these sounds, right? So we process this data in a way that leads, so this is the EEG data. Like I said, it's everything that's happening in the environment, including, our stimulus that's coming from the speakers. And then we're going to get to the event-related potential. But I just want to show you that you can do this with babies too. So this is one of my lab mates' son at the time. I think he was 4 months old at that time. I think he's in high school now or whatever. But I'm sure he doesn't know that his mom allowed us to use his picture. So this is to just show you that this is very safe. And I've also been involved with studies with infants, and we can. It's a very effective tool because infants, they're not going to actually follow directions and tell us what they're hearing or whatever it is. So okay, so you take this data, and the data has sort of in them the response to our stimuli too, and we post-process this and convert them to waves that you will see that look like this. And so I just want to tell you 2 things about the waves. The measurement is in voltage, and it's actually really, really tiny, even though on the screen you might see big looking waves. They're at the level of microvolts. So no one's shocking anybody. We're not shocking ourselves or whatever. It's all good. And the amplitude of the response is a measure of how effortlessly or how well your brain is responding to something. So a bigger ERP here stands for, at least in these studies, stand for you're doing this well. And a smaller one in amplitude stands for you're not doing it so well. And then we also look at, even though I'm not going to talk about this in these studies that I'm going to talk about today, you can also tell from these waves when in time things are happening. So this methodology, unlike the functional magnetic resonance imaging, which is so popular and has nice pictures. This can also have nice pictures, although I didn't include the nice head pictures that we could get from here. But my point is, this tool tells you how our brain does things and when in time it does things, whereas fMRI, or functional magnetic resonance imaging, tells us where in the brain things are happening. So they're not they're not competing methodology, but rather they're complementary ones. So now the data from our 3 groups of people. So to read them, again, coming back to the amplitude, the bigger the diamond shape you're seeing, the better that group is doing. So there are 2 sets, because these are on the left, these are data from the left-sided electrodes, which give you information about the left hemisphere, and the other is from the right side, and we didn't really see any difference between them, but That's how we show our data sometimes. So as you can see, whether or not you know about the ERP methodology, it's clear to you that the top 2 diamonds are the biggest, and that was our monolingual group. And then the bottom diamonds are from from late bilinguals, and that's expected. Already I told you, even with attention, right, they were not doing so well. So of course, without attention, they're not doing well either. But the middle group surprised us. We thought they were going to be as good as monolinguals. Where in this study, these people were closer to the late bilinguals in their preattentive discrimination of these sounds than the monolinguals. So going back to our questions, how does the amount of L2 exposure affect processing for vowel contrast? It's not present in one's native language at a preattentive level. So what we saw in this study is that early bilingual and late bilingual adults are similar and less automatic in second language vowel perception than monolingual adults. But what about at attention-dependent level? So early bilingual adults, we saw that they process second language sounds like monolingual adults, while late bilingual adults still struggle with them, albeit with attention. So that's what we saw in this study. So now we wanted to explore the nature of how attention is working at the preattentive level, if you will, in another study. And here we included both adults and children. So the title of this paper is Automaticity of Speech Processing in Early Bilingual Adults and Children. So now we are focusing just on the early group, people who have been exposed to 2 languages since childhood. But we looked at adults, but also school-age children. So we're going to talk about the adults first. So the first condition was the same as the condition in the last study, which was they had a set of sounds, repeating vowel eh, and then dispersed it vowel, and they watched a movie, the sounds came in the background, and we recorded data to see what their brains were doing. We call this the ignore task. But we also, wanted to see how their brains would respond if we drew their attention to the auditory modality indirectly. And this is to say, there were no tasks in these attend tone and attend speech conditions where we said, tell us which is the I vowel and which is the E vowel. What we did was we added another auditory condition and got them to attend to that task. So here's what I mean. So in the attend tone condition, we included a high frequency and a low frequency sound. And we told these participants, sometimes in this auditory stream of events, you will hear a high tone. Press a button. So now they're not directly paying attention to the vowels, but now they're not watching the movie either, right? And in a similar way, we had a speech condition. So instead of putting tones in there, we put a da and a ba sound, and we said, every time you hear the da sound, press a button. So, and this difference has to do with, the similarity and differences between tones and speech, and you want to see which condition might get them to become more automatic. And by them, we meant the early bilingual adults. So we remember in the last study how the early bilingual adults were not looking like the monolinguals. So we thought maybe if their attention was directed to the auditory stream, maybe then they were going to look like the monolingual adults. Like that is, there would be no difference in the attend conditions between the monolingual adults and the early bilinguals. Okay, so I'm going to familiarize you with 3 terms because I'm going to show you, and it's not important you remember the terms, but I want to tell you about them because you're
What intense?
Because in the last study, I just showed you that one diamond thing, which was the mismatch negativity. But here I'm going to show you 3 different event-related potentials that tell us the story, if you will. So the one that I showed you in the last paper, and the first thing that I'm going to show you here, is called mismatch negativity. And that's that whole oddball paradigm thing where we record responses to the repeating sound, then we record, we record it together. but we are also recording responses to the rare deviant sound, so to the S sound, to the I sound, and we're subtracting these responses to see whether there was a difference in how they responded to the S sound and to the I sound. So that's the mismatch negativity, because there is a mismatch between the two types of response. And it's a subtraction rate. We actually do a mathematical subtraction. And it's about preattentive discrimination. We also see another component called late negativity, and this is not as well established a component as mismatch negativity, but it has been associated with reorienting attention in more complex stimuli or more complex cases of auditory effects. And then the third component is a processing negativity, which is also related to attention and is an early component. So in these ERP things, we have things that happen very early and automatically, and some that are late. So the late negativity is more of the later brain process, meaning there's more cognition coming in, if that's one way of looking at it. Whereas the mismatch negativity is pretty automatic, and the processing negativity also is automatic, but it's attention related, not language related. All right. Okay, so this is the result from the mismatch negativity. Excuse the very small headings, but these are actually graphs from the paper. So on the left you have the monolinguals, and the right you have the early bilinguals. So what do you see here? Are they different? Would you say they're different? I mean, just from visual inspections, do these or if in particular do the dotted lines look different? Not really, right? So they were in fact not different. So in this study, the early bilinguals across all the three conditions were literally identical to the monolinguals. If you have questions about that, we can talk about that later. But we expected to see a smaller mismatch negativity for the ignore condition, but we didn't. And so none of the conditions, in all conditions, the bilinguals and the monolinguals were similar. But when you look at the attention-related things, things were slightly different. So here, now we're looking at the late negativity, which is the green dotted line, right? And these here, across the different conditions to put together, there was a main effect of group, meaning that the early bilingual participants had a larger late negativity than the monolingual participants, right? So this didn't mean that they were discriminating the sounds better, but it's about how they were doing it differently, right? Whether they were discriminating better or not is from the mismatch negativity. They were just like the monolingual, they meaning the early bilinguals. And then here I show you the processing negativity. So the processing negativity is not even about the contrast. It's about how they were allocating attention to each of the sounds, how they were allocating attention to the S sounds and how they were allocating attention to the S sounds, the I and the S sounds individually. And again, you see on the right, these are the bilinguals, and just follow the green line. That will tell you the story that the monolinguals didn't even have a significant processing negativity. So they're not doing anything different with attention when it comes to the sounds, whereas the bilinguals are intensely attending to all the sounds. That's how you should read this, right? Not just intensely attending to how to discriminate them, but to all sounds, right? So how do early bilingual adults perceive brief English vowels when when attention is drawn away from the auditory modality? So monolingual and early bilingual adults demonstrate no difference in how they process English vowels automatically. They're both automatic. But when attention is drawn to the auditory modality, bilingual adults allocate more attention to speech processing than monolingual adults do. So overall, their brains are very intensely attending to the sound so that they can be like the monolinguals. Is one way of thinking about it. So moving on to the children. So here's a little bit of literature on what goes on with children. In this entire literature of bilingual speech processing, maximum work is done on the late bilinguals because people have wanted to process for the longest time how are we going to survive in an immigrant country if you go there late. So let's find out what happens. Can we ever learn this language and so on and so forth. But largely speaking, the world is bilingual, and almost a lot, more than half the world are exposed to 2 languages or more early on. But there aren't so many studies when it comes to early bilingual adults, and very little for children. So one thing we do know is that early on, bilingual children may not be performing like monolingual children, but as soon as they're immersed in their second language and they're going to school, there's evidence that one paper suggests that by 10 years they are just like monolinguals, or they're very native-like in their speech processing. I wouldn't say just like monolinguals, but very native-like in their speech processing in L2. And then there's evidence that at younger ages, with more exposure, their L2 processing gets better and better, right? So in the last bullet is about how researchers have documented larger mismatch negativities, larger late negativities with exposure to L2 in preschool, daycare, school, and what have you. So for this part of the study, the goal was to understand the relationship between attention and speech processing in early bilingual school-age children. And our kids were 8 to 10 years of age, and they did the same task. Everything that they did was the same as the adults that I just talked about. So again, how do these early bilingual children perceive brief English vowels? And now we're comparing them to monolingual children, but also to the adults, right? The bilingual adults and the monolingual adults. The same 2 questions. I'm sorry, there's an error here. It should say, when attention is drawn away from the auditory modality, not attention modality. All right, so I'm going to show you all the graphs, but just to cut to the chase, in the children group, the monolingual and the bilingual children, they were identical across all conditions, but they were different from the adults. So already, without going into the details, you can see that their blue and red waves look kind of different than the adult waves. So I'm going to go back to the adult waves. Look, you have this like small bump and the large bump. So, but that's not true here, which means that their auditory system is not fully matured. That's one takeaway, but that's true for both bilingual and for monolingual children. So their mismatch negative is equivalent. They're able to process the sounds. This is their late negativity. Remember, in the early bilinguals, in the adults, the early bilinguals had the bigger late negativity. That was not the case here for the children. Both groups had a late negativity, and they were similar. So, they need some attentional resources to do this task, which the monolingual adults didn't really need. And then this is the processing negativity. So here you see that the monolingual group also has a processing negativity. Unlike the monolingual adults, they didn't have one. Meaning, again, the children, they're attending to the sounds at some, unconscious level to be able to do this task. So they're not like the adults yet. But language exposure is not making a difference. That is, whether you're monolingual or bilingual, you still need the attention to be performing masterfully, if you will. So early bilingual children and monolingual children are identical in processing English speech sounds with and without attention, and early bilingual children are different from bilingual adults in how they allocate attention. So at this point, we can say that late bilingual adults cannot process speech automatically with or without explicit attention. Early bilingual adults process speech differently from monolingual, especially when it comes to allocating attention. And children, monolingual or bilingual, are not fully proficient in speech processing or allocating attention to speech stream. So if you're tired, I will not go over this study, or I can go over this study. It's not as painful as the other ones. Not even as a participant, it's not. I've not talked about this study in a while, but I think it's really interesting, because now we're talking about words and how speech cues words. This is a study from my postdoc, and here we were investigating what Japanese English late bilingual speakers, how they deal with things. And it's not an ERP study, but we can say something about speech processing about this. So regardless of their non-monolingual speech processing skills, bilinguals, or any non-native speakers of English are able to function in the second language in real-world settings, right? Even if you have an accent, even if you, so all of you who raised your hand saying that you have some bilingual exposure, if push comes to shove, you'll get some words out of somewhere, right? And that's in a continuum. So we wanted to explore how non-native English speakers are able to recognize auditory words despite their poor speech processing skills. So, you know, I already showed you that late learners are struggling with speech processing. So how is it that they understand you if they don't do this well, right? So then the idea is perhaps through some top-down or anticipatory processing. So and as adults, we're doing that all the time, all right? So the idea is to see, oh, you know, as a bilingual, what are you doing with that? So the questions were, what type of anticipatory cues do second language speakers of English use? Do they use acoustic or sound related cues at the articulatory level? Just think of it as sound cues. Or do they use visual word context? So if Melissa was to say, here, would you like some coffee? I would kind of think, oh, must be, she's saying, would you like some coffee, not would you like a coffin, right? Because there's no precedence for that here, whereas I can see the coffee cup. So that's what I mean by visual world context. So we actually just used a laptop for this. And what we wanted to see is how there were two pictures and there were words that came on. We wanted to see, given the two pictures, how the participant clicked on to the correct picture, what their mouse trajectory was. And again, to the psychologists in the room, not real mice, but the mouse of the computer. This is how, I don't know if, right. So what, I'm going to show you the trajectories you'll see. So what they were asked to do was not lift the mouse, so not click like this, but start here. That's why the start button is there. And they had to click like this. And we wanted to see, depending on the pictures and the stimuli, if they got sort of diverted towards the wrong picture or not. So what do you think this picture is? Neck. And what is this? Net. And as you will appreciate, that neck and net, they have the same onset, right? They sound same in the beginning and not the same in the end. So not only we had similar stimuli like this, but we actually, what we are able to do from another paper that had been published a while ago is take a portion of the neck from, a portion of the word neck, the first portion, which is neck, and then attach it to the toe of the net. And maybe those of you who are not from speech, it's okay. Those of you who are not here from speech, you won't realize this, but the net from neck is different actually than the net from net, even though it starts the same way and you think they're the same sound, they're not. Because when we say neck, our tongue prepares differently. And because the last sound is a ka, and we're going to make it from the back of the tongue. So our gets, it is not as much of a front sound as it would be for the word net, because the ta is a front sound. So this has to do with this idea of co-articulation, meaning we are really efficient speech producers too. So we don't talk like this, right? We say neck, and as we are saying na, in fact, our tongue is also preparing for e. As we're saying e, it's preparing for ka. So that's why each sound is influencing the sound ahead of it and behind it. So that's what co-articulation is all about. That's why the ne in neck is different than the ne in net. So what we did was we spliced on these different endings of words to different beginnings of words, because suppose you hear the real word neck. That's well and good. As soon as you start hearing neck, you get that cue for the fact that it's going to be ka, and you click the right word, right? Same with net. You go directly to the right place. But if I cross-splice it, and I have the ne from the neck spliced onto net, even if the actual word is net in the end, in the beginning, you have the tendency to go towards neck because you think, oh, I'm going to hear neck. So it sounds like net. and then you're like whoosh going towards the neck, but you're like, oh no, that's not right. So this is what we wanted to see, if what the pictures were and what people heard, how these influence each other. So I don't know if these are going to play. I had embedded them a long time ago, and now each time I want to play, it turns itself into this weird looking happy birthday present thing. So we're going to try to play it. So is there any way I can increase the volume?
On the screen you can. Oh, I guess it's at full.
It's a little more room on the box.
Okay.
Let's try it.
Okay, so that's neck. And then this is a real net. So this is one from the neck onto the toe. And this is from a non-word. Nap is not a word. So we also had that kind of a. Do you hear how you kind of think there's a pie in there, but there is not.
Mm-hmm.
And this is an unrelated word. Right. So here we see how the trajectories look. And what you see, so the English speakers are in blue and the Japanese speakers are in the red group of colors. So you see that the most diverted trajectory is for those words that were cross-spliced from the English speakers. And then the light blue is also cross-splicing, but it's from an unrelated word. So even if you think you hear a nap in there, it's like, oh, that's not even possible. Like, there's no nap, and there's no picture of a nap thing. So it must be net, right? So it's not diverted. Remember, neck is on this side and net is on this side, picture-wise. But the Japanese speakers, as you can see, they just go directly to the net because they're not able to really take advantage of the neck picture there. They're not actually able to take advantage of the visual context like we thought they were going to be able to. And this is unspliced, so that those are all real words like neck, net, that, and they, as you can see, the mouse trajectories are not diverted like it is in the other, and everybody's pretty similar in that way. So what we learned from this study was native Japanese speakers were somewhat less sensitive to enhanced competition from misleading acoustic co-articulatory cues. So they didn't hear these small co-articulatory differences. Also, they do not appear to be able to take advantage of visual world context as predicted, but perhaps because their English skills in general are not as good as monolinguals. That is to say, they don't even know as many words, right? Remember, these are not early bilingual speakers, right? So maybe if we had tested early bilingual speakers, we would have seen better use of visual world context, even though they would have had maybe less acoustic bottom-up cue processing. So this is sort of the takeaway. If you're a monolingual adult and you have experience with only one language, your brain becomes extremely good with that in terms of speech and language. You're highly automatic. You don't require increased attention to do everyday speech processing, and you can easily capitalize on linguistic context. If you're a late bilingual adult and you have experience with only one language for a long time, adding a second language later in life, it's likely that your brain cannot process second language like native speakers. You are not automatic in L2 speech processing, and increased attention is crucial in everyday speech processing, and you're probably aware of it as you're doing it. You're feeling the effort. But you still don't function like native speakers despite putting in all this effort, and you cannot probably easily capitalize on linguistic context. If you're an early bilingual adult and you have experience with two languages since childhood, it's likely that your brain processes second language like native speakers or like monolinguals, but not in the same way, right? You're not as automatic as L2 speech processing as monolinguals. Increased attention is crucial in everyday speech, and you're probably not aware of it when you're doing it, but some days when you're operating your second language for a long time, you might feel exhaustion at the end of the day. And you do this in order to be like native speakers. So at the front end, nobody can tell that, oh, you speak 2 languages. And you may capitalize on linguistic context in L2. And then if you're a monolingual child or a bilingual child, you're not as automatic in speech processing as adults, and increased attention is crucial in everyday speech processing, whether you are just experiencing one language or both, right? So I have a slide after this too, but if you guys have
Well, you know what I would like to do, if it's okay with you, I'd like to give her a round of applause so it ends sort of the talking at part. That way we can do questions and then conversation, and we'll leave that up for now and open it up to any questions that you might have for now. And those of you who are out there, if you want to unmute your mic and ask, but be patient with being responded to. So if that makes sense to start. Does anybody have any questions here? I do, so just please go.
On early bilingual child, do you mean total immersion or through school?
Either. So our early bilingual children, all our bilingual children actually can be tested late. I mean, there's not a possibility of late. In this age group, who were 8 to 10, they too were all exposed to both languages before 5, but we didn't. I mean, right now, I don't have any data on how they were exposed to the 2 languages. They could have been from birth, could have been sequential, meaning one after the other, meaning one home language and a school language is English. But what we know is they did use their languages. They didn't only, how do you say, stop using their first language, is what I'm trying to say. So yeah, they might be immersed in L2 in the community and school, but they still had exposure to their first language. They continued that exposure.
Okay. I'm just thinking of kids in middle school picking up Spanish, let's say, can they become?
Yeah, they definitely can. But again, I mean, I think that most literature shows that onset of a second language in mid school, it might be harder to become very native-like than if you start earlier. But doesn't mean that you can't learn. And there's also literature that suggests some of this is modulated by how much you use the language, right? So I did not learn. Let me say this right. I did not immigrate to U.S. until I was 25. I learned English since 3 in school, but you have to understand, speech-wise, the English was like how I was talking in the beginning. Actually, not even that, because I think people in India now think I speak with an American accent, even if I speak like this, because it's so far from what I did before. I'm going to switch. So I did not actually learn it this way. That I learned after I came here, but I still sound non-native. I mean, people can tell that I didn't grow up here. So I forget what the point I was trying to make was the accent and all of the, so use of language definitely makes a difference. Yeah, even as an adult, immersion definitely helps.
Thank you.
You're welcome.
Please.
I was just curious if you've ever thought about or like you ever looked into people who are deaf and don't hear, and then when they get, a cochlear implant or some sort of surgery, to hear how this would affect them, you know what I mean?
Right.
Because they don't have any hearing at all.
Sure. So a couple things. I don't know. So just to put it out there, that I don't know of any studies with bilingual cochlear implant users. That is not to say there is not one out there, but it would be very rare. Second is the world of cochlear implantation has moved along rapidly over the past decade or earlier, probably, in that earlier and earlier people were implanted later and later, meaning once upon a time, people were implanted maybe as adults, and then maybe in like middle school, and then maybe kindergarten. But now, babies are being implanted because we know that that's the best practice, and then it's not like they don't hear, right? So then coming back to your question, I don't know that people have actually investigated what happens in bilingual cochlear implant users. But the other caveat there is, I think that there's in speech language pathology, including cochlear implant users and Dr. Schmidt can tell us if I'm wrong, that there's this fear of exposing kids who are disordered in any way to multiple languages. Because people think, okay, this is impossible. We can't even learn one language, and then, what do you mean we have to, maybe we shouldn't speak our home language or what have you. So finding participants who are probably bilingual in 2 oral languages would be difficult. However, it's possible maybe to find bilinguals who use ASL and English who are now cochlear implant users who got implanted later. Would you agree?
Yes, I would.
Yeah, that's a cool idea.
Right.
That's thinking of connecting. This is our biology major who's now a nursing second-degree student who would make those connections. So I'm going to try 1 or 2. I'm going to do 2 ages on the continuum. The 2 ideas that I would love to find a way to work together. One is because you talked about processing, cognitive processing, which takes a period of time. And you started out with early dementia and Alzheimer's and those kinds of clinical problems.
Sure.
One of the things that I think would be really interesting is using using that technique. I'm always looking for cool techniques. By the way, I did a bunch of stuff with infants too, with split screens and systems, and those are really fun kinds of techniques, and it really gets at good measures. This looks like a really interesting measure in an aging population where speech is less relevant to processing hearing. Sure. And I know you have to rule out where there's hearing gap, but that's one end that I think our students who are geriatric inclined would like to do to look into it. One of the things I think is if you were thinking in terms of intervention and language use, the use of Amazon shows in adults who are by themselves and not speaking at all in terms of cognitive processing, if they were visited and engaged in conversation, that immersion idea, that maybe there would be a way of showing that that time period of processing shortened. I mean, that's kind of what I got from this.
Right.
So that latency, that delay.
Right.
I think that might be a cool measure, a proxy measure for it.
Right.
But the other end of the spectrum, which would be even prenatal, I know some studies that nurses are doing that look at electrophysiology of babies in utero, having exposed them to sound.
Right.
And the sound is mother's voice.
Yes.
So mother's voice as an immersion. The kind of people that you look for the right eligibility. That your question is interesting for me personally. My best friend had 4 children. She adopted from Chile, the youngest, and she'll probably listen to this because I'm going to make her listen to this. The youngest was 4 when she came. She was early, but they did not use Spanish in the house. So today she's a high school principal and teases that she's not a fluent Spanish speaker she is now because she learned it sort of later. She didn't learn it early, where her brothers and sisters learned it early. Her new baby is being raised, and he's very small, in a bilingual, immersed home. And he flips between both in all of his learning. So I know the literature I know on cognitive development of kids is that some of their behaviors are delayed when they're back and forth in language. The scores on tests, I'm not exactly which ones.
Yeah, I mean,
but when that all comes in, they're more
right. They're very slightly delayed. It doesn't really clinically affect them. Would you?
Yeah, exactly.
Okay.
I mean, they're doing a lot of because they're doing a lot of code switching, which they don't even realize.
Right, and the standardized.
Sorry. I also think it's generational. There's a cultural aspect of there was a point in pedagogy and general education to
prevent you from
Correct.
being bilingual
Right.
and label you as having
Right.
special needs and not
Right.
able to process well
Right.
because of it. And so it depends.
That's part
when
of
those
them messed
studies
up in
were
that
done.
kind of
Correct.
data.
Yeah.
Right.
And
Correct.
it's a different
Right.
acceptance now and
Right.
exposure
Right.
and teaching.
Right.
So,
But also in schools, that children are often identified as being sort of slow in learning, but only because the teachers themselves cannot distinguish between these language variables and the learning.
Right.
And the
Right.
cognitive skill may be
Right.
fine and they're
Yes.
catching on everything. It's
Right.
their ability to
Right.
integrate it in
Right.
one language.
Right,
That's
and that's
really
why I know
the
that Clara, if you listen to
Right.
this, Clara knows that it will be a benefit for
Right.
Right.
her baby.
I mean, for Clara's baby, I don't know Clara, but for Clara's baby, the baby, as he or she goes to school, will experience no difficulty at all. I mean, I can almost certify it, if you will. But if Clara was living in Chile and her baby, and they both moved to U.S. when the baby was 7, and all along they're speaking a different language than English, and then the child is going to school, and suddenly the speaker and everybody's speaking in English. It's like us going and sitting in a Zulu class, and then we'd be like, wait, what? But if the difference between us and Clara's Chilean living baby, who's now in English environment, is he will pick up fast. And by the time he's 10 or 12, there will be no difference again between the American babies and the
She actually
children.
brought him to Chile last summer.
Right.
That's really perfect example. What I think is very cool, they happen to live in LA. They happen to live in an environment that is probably more immersed and bilingual.
Right. It's
So-
conducive to raising her children that way.
Exactly.
Yeah, and that matters so much. I mean, it's so hard to raise my son bilingually. I mean, clearly his English is his go-to language. He has some very rudimentary probably structures in Bengali. He will say it back to me if I prompt him to speak to me in Bengali, but his initiations are all in English. And I'm reading to him a lot in English because I don't have as attractive books for that age in Bengali. And that is something that you might ask your friend Clara
My second daughter.
to expose her child to Spanish reading. Because the kinds of language we get from reading, the kinds of structures we get from reading, we do not get from, speaking, because we're not in a Ph.D. program speaking like this all the time. So it's very, very
I
important.
think she does, and I think again, I don't know if she has, this is fantastic. This is really, really good to show drilling down to it. I hope my nursing students who will listen to this can see that you can think in a completely different way to ask questions. That's kind of the goal of doing this. So anybody else?
I have another question. I'm sorry. So not coming from speech background whatsoever, I'm curious if it's, so I come from a dual language household, but my parents didn't teach me the second language. So I don't actually know it, but my mom is from Italy, born and raised. And when I went to Italy a few years ago, and we spent 2 months there, by the end of being there, I understood everything. Is it possible that it gets stored in you somehow? And then it comes back up?
I'm going to answer it with some data in the literature, with some evidence from some data in the literature, but I have to ask you a question first. So you're, as a child, even though your parents did not explicitly teach it to you, by which I understand they didn't speak to you in Italian, is this correct?
No, they did not. Yeah.
Okay. But would you say you overheard Italian somewhere?
Oh, I always hear it because my grandmother lives with me and she only speaks Italian.
Sure. So I go back to the first thing I said. The bilingual brain is not about knowing 2 languages perfectly.
Yeah.
But your brain is certainly different than mine when it comes to Italian. I don't even know one word. Oh, I do know agita. In Italian.
That's a good one.
I love it. But I don't know anything else. So if I went to Italy for 2 months, I would not understand Italian as well as you do because of your exposure. And then going back to the adoption piece and your question, there is literature from 2 studies, at least that I know of, where investigators did fMRI scanning on Korean adopted adults here in the U.S. So they're adopted, meaning like your friends' daughters, they had some exposure to Korean when they were very little, whatever, 2, 4, however, whatever age they might have come here, and then completes, no Korean, not like you even, no Korean whatsoever. But their brains, so these adult Korean adopted American adults' brains to Korean reacted differently than yours and mine. Meaning that I don't know if I should use terminology like stored, but definitely, your one's brain is, a sponge in amazing ways. How every minute of exposure to the environment changes our brain a little. Do you know have you heard of this person, Eric Kandel? Okay, so he's a neuroscientist in Columbia, and he's a dear old looking man. I don't know him, but he looks so like grandfatherly. So he says, it's your brain, every day your brain is, you have a different head every day or every moment, because your brain is just a little bit different as you're absorbing the context of the world.
That's very interesting. Very cool.
So my question actually dovetails on that, because I was in that same situation with my grandparents, who spoke Italian to each other. My parents spoke Italian to my grandparents, who lived in the house, spoke English to us.
Oh, yes.
I did have some knowledge of Italian, and I still know some of the words. I learned to count, all that kind of stuff, that kind of drilling kind of thing, but didn't use it much once I went to school.
Right.
Same experience when I went to Italy. I wasn't there for 2 months. I was only there for 10 days. But, but I think using I had to attend very carefully, a lot of contextual cues. I could figure out what was being said. Now, is there any hope that I could ever regain some fluency in Italian? That's my question.
Yeah, I think more so again than me or my Asian friend Yen, who did that basketball thing for me, who we have no exposure to Italian. So you definitely, my opinion is you'll definitely learn Italian better than us, because we have no context for Italian whatsoever. But your young brain had some context. So it's the young brain too. It's not like me now, like, having some exposure to Italian and going to Italy, but your young brain had it. So that is an advantage. But whether you'll speak Italian like your grandmother, it's to be seen, depending on how much exposure and how much use in some people or some investigators think in natural context you have of Italian.
Because the understanding piece is so much easier than making the words.
Right, that is the case.
100% I agree.
Yeah.
But I mean, that's true even in children.
Yes.
The ability to understand the spoken word, far, exceeds the ability to
and comes before production, right? So, the 1 year that babies don't speak, you think they're doing nothing with them.
They're taking
Well, that's the reason why. That's why the reason of these studies prenatally of having language exposed before the babies are born, showing evidence of early acquisition of language and understanding mother's voice. And those sorts of studies. But also the to add into that the clinical aspect of it. My neurodevelopmental foundation, my Ph.D. in human development and family studies, is the plasticity of the brain and the attempt to try and say of when too late is too late. That critical period paradigm.
Yeah,
this is great because this is changing. This is saying you can develop new
absolutely
curves and lobes and
I mean, there's in that well there are evidence now that that the neurons in our brains are more plastic than we had imagined. All this data coming in, also doing animal studies with real mice and talking about
real mice.
I have to real mice and trying to use that data to see if we can do anything clinically for stroke patients, right? Because the big issue of plasticity right there with brain damage, what plastic areas in the brain can we take advantage of under give therapy? So those are all very interesting. I do want to show you my next slide because some of what you said, Ronnie, is kind of in here, but differently. These are very how do I say, not exciting ideas.
No,
or
no,
very,
this is
very
no,
obvious
no,
ideas.
No.
But I just wanted to throw some out there saying that, there are all these, there is, the last point, there are actually interesting data suggesting, again, more preservation of, later onset of dementia and better aging brain with multilinguals or bilinguals. So it's all very interesting. And the basic idea actually is not even language here, it's how you exercise your brain, or if you're continuing to do so. So, it's not like, oh my God, I never learned to say language, I'm doomed. It's not like that. But so it's all
and realizing, I guess, in these medical settings for all of you, that sometimes what you're seeing in a stroke, for instance, which I'm not really involved in the current research, but is that someone will have a stroke and only one language is affected.
Yes.
And so the physicians may not realize if English has been affected, but maybe an older language is preserved.
Right.
And it may take a while
Right.
to kind of get
Right.
that
Right.
out.
Right.
And
Oh,
that
yeah, because
happens.
you've seen that. We've
Right.
seen that whereas
absolutely.
people age and either from
there's a
stroke
whole
or some
literature
kind of
on
brain injury.
by
that they
people
revert
who
to.
speak multiple languages and how it comes across once you have a stroke and which most often the recovery of your languages is kind of mirrors the proficiency of your languages. But there are rare cases where, you didn't use this one language for 20 years, but suddenly that's the language you're speaking in, and nobody anticipated that because you look, like you should be speaking these languages, and why are you speaking, this Thai or whatever it is that you're speaking. But there's all these interesting things, and then how the environment is stimulating what language back. So in a medical setting where these patients are there for 2-3 weeks, at least in acute care, and then other settings, these are important for caregivers and, medical support to know about when interacting with.
I think that's good. One of the assessment ideas to add is I don't think when in NICUs we even identify, we'll say, where are you from, where are you born, but we don't ask what's your name, how much bilingual ability one has.
Right.
We'll try to communicate, we'll call up the telephone and they'll have the translators to come in, but we don't have any sense of that, and we're working with moms most often, and that's another area that
and it's important to ask those questions correctly too. Again, if you use the term bilingual, people will say no, and then you find out it's not true at all. Like they have a different home language, but they feel like they can't claim they're bilingual or some such self set standard that has no meaning clinically. So questions to ask is what are languages used in the home, or what languages do your child or a family member, what language are they exposed to? These kinds of sort of neutral words so that they can give you the real answer.
That's really good. And I'm going to ask from the outside. I didn't check to see if anybody's still there, but we're going to pause for a minute and see if anybody from the outside, from what I call in Cyberland, or if you want to unmute your mic and ask any question. I know, Lisa, you wanted to start, so if you're still there.
No, actually, I made a mistake, Ronnie. Sorry, I didn't realize that.
No. Go ahead. Please ask.
But anyway, yes, I actually, first of all, I want to say thank you. This was very, very interesting. And just thinking clinically about ideas for collaborative research, as nurses, our aim is to practice patient-centered care and to engage patients in what we call shared decision-making. And so this issue comes up all the time with our students who are caring for patients for whom they want to be culturally sensitive but have difficulty with communication. So I think one of the areas we could really collaborate on is how do we best engage individuals who are, let's say, late adult second languagers, as we're trying to really elicit their input and their decisions about how to proceed with care, and how do we confirm what they actually process? I mean, I know this is a question, but
the big area that I'll join you in that is health literacy, and it's so fascinating of how that's interpreted. It's interpreted in so many ways, but that's the big area that for sure joins us both.
Right. I think the checking in piece is very important. Like, how do we know they are processing what we are saying to them? one simple way is asking again. Like, so this is, what did you, so I gave you these directions to follow at home. Can you repeat, what those are? I mean, and repeat, I use the word loosely just to see and that's such an important clinical practice, I think, and not just for bilingual patients. I think in the entire medical setting, because we have a way of telling patients what we think should be done, but we have to remember they have not been exposed to any of these, advice or literature or what have you. So they may totally have a different context for it to understand something completely different. And this is communication to me, like, is so interesting because of this aspect, like what we say, what the other person hears. And
yes, and you're saying, what I hear you saying is that goes for those who are English speaking as well. Which is
yes, absolutely.
Last night, Davina, if you're still on, last night in my lecture, I used the example of when a mom is given an antibiotic in liquid form for her baby for an ear infection, and she takes it home, puts the drops in the baby's ears. That's because there was no way of knowing. And when I was at the Institute of Medicine at a health literacy conference for physicians, the speaker on the stage said, nurses do it better because the language that we use is return demonstration. Whenever we teach, and it's not just nurses, but it was really interesting in this room full of physicians, it was nurses ask for return demonstration, which is what you're saying.
Yeah, no, absolutely.
It's great. It's good. Anybody else out there? Hearing none, and being that it's 1:30, thank you very much.
Thank you.
I'm going to close you down and stop the recording. So,
Nobody had any lunch to eat.
No.
I mean, brown bag is like far off. I mean, no lunch. Bye. Thank you guys for coming.
So interesting.
Thank
I
you.
think this is fascinating, isn't it? Just, I mean, just because I always talk about this with like other people, because I come from such a strange household of like bilingual but not bilingual. You know what I mean? So what's actually very funny about this is the language that I speak other than English is not Italian, it's actually French. Because I took French in my other degree as kind of like I wanted to learn it. And what's funny about that is I have cousins from Canada who speak French and then they speak Italian and not much English. So they came and visited me like a few weeks ago for my grandmother's birthday, and they don't speak English, so we're kind of trying to communicate brokenly. And then I remembered that they speak French, and I was like, oh my goodness,
It's a Romance language.
Yeah, so I spoke French to them. I'm interested to know if French, because French, English, and Spanish are supposed to be very